Okay, good morning. My name is Stephen Spear and I would like to welcome you to Intercope's ISO20022 migration webinar for Box users, but also for anyone else that would like a better understanding of what is about to hit us over the next few years. Now, this could be as early as November 2021 or potentially 2022 for certain market infrastructures. And this will mark the beginning of the migration of payments, securities, cash reporting, to name but a few areas, to the new ISO 20022 standard. We should not downplay, I think, the enormity of this migration, which will impact the way banks, financial institutions and market infrastructures are able to exchange local and cross-border instructions and reports. And the aim of this webinar is to hopefully provide a high-level set of information on what is truly about to take place, and also how Box is placed to meet all of your challenges that our customers will face moving forward. So let's take a quick look at today's agenda. Now, these are the areas that we'll be primarily focusing on, and I'll briefly run through the sections in case you're watching this offline and you prefer to move to a specific section. So areas of market impact, we'll take a look at a few of the key areas that the Intercope Box solution is utilized in today and how those areas will be impacted. For ISO 20022 message usage guideline changes, we'll look at what guidelines and standards are currently being used today, by who, and who is actually driving the usage. For FINplus, what is it? What runs over the rails of the network that the service will run on, and why is it an integral part of the overall migration? And then we move on to more Intercope specific topics and solutions. For Box message entry, how will the new addressing take place? How will Box interpret the new messaging standards? Now, a big part of the migration will be a coexistence phase, where specifically Swift MT and MX messages will be sent, received and converted. And then Box Payment Warehouse. Again, with the coexistence of MT and MX messages, customers require an easy option to track, view, action their messages without the concern of what format the message will be in or how it can be searched or viewed on the system. For Box Message Validation, how do you drastically reduce the level of risk in regards to inconsistencies in the syntactical or semantical formatting and content of a message to reduce and remove the need for human interaction? For MT conversion and coexistence, so one of the most important areas here, this will truly show the power of the Box solution. How does Box convert MT to MX and vice versa? How does it get around the issues of data truncation and the added complexity and granularity of ISO formatted messages? For ACNAC handling, we'll take a look at the market infrastructures like the Eurosystem, who will be moving from a Y copy processing model to a Swift V-shape model for real-time high-value security payments, along with financial institution to financial institution serial flows using the new MX schemes. For message content modification, again, you'll see the power of Box through the conversion process, and we'll take a look at how the power of the workflow will play a big part in reducing the complexity of additional steps that would have to take place outside of Box, which will come at a cost, of course, if not built within the Box workflow. And then sanction screening. Now, most organisations today will have an embargo system in place, but they may not have thought about the complexity that will come into play if your embargo engine cannot read the newly formatted MX messages. We'll take a brief look at how Box tackles this issue so the customers don't have to. And then RMA evolution. Now, specifically for Swift, the move from the Fin network to the SwiftNet network will require institutions to have new RMAs in place, which are equivalent to their relationships for category 1, 2 and 9 MTs. And we'll take a look at how the risk around this will be mitigated and how Box will show those relationships at the same time. Okay, so let's begin with an overview of some of the most strategically important areas in terms of global adoption and also Intercope's Box usage in the marketplace. Now, as we all know, ISO 20022 is a global standard for exchanging electronic messages between financial institutions. And this has been driven towards institutions on the basis of providing a number of key benefits. Lower IT support costs, easier maintenance, an increase in the richness of data which is being transported, just to name a few areas. But I think the most important aspect when you look at the overall end-to-end life cycle of a message is the increase in straight-through processing or STP time between institutions. Now, this has become increasingly important in terms of instant payments. By standardizing and moving away from a lot of the proprietary solutions which require manual changes, you automatically speed up and reduce the amount of manual processing required to move transactions through the chain. So in a world where speed is now key, a number of market infrastructures and network service providers are really driving the adoption of ISO 20022. Now, I won't cover all items here, but I think it's useful to take a look at a few examples so you can see how complex this move will truly be. Now, in terms of network providers, and we mentioned the likes of Swift, SIA and EBIX here as examples, the move to ISO 20022 is either driven by the network provider due to the message structure and content that move across the network rails. Now, Swift as an example will move away from its MT message format for MT 1, 2 and 9 message types to the new XML formatted message. Swift is driving this adoption along with a workforce of institutions to come up with the guidelines required to successfully send and receive the new types of ISO messages. The migration plan date was 2021, it's now been moved to 2022. Or if we look at market infrastructures, the Euro system is a good example here as they own and operate the Target services. Target is the Trans-European Automated Real-Time Gross Settlement Transfer System. It settles in euros, cross-border and domestic, and is a high-value payments platform. The Euro system will move as a Big Bang approach in 2021, and by doing this, they will be impacting the Target 2 RTGS service, the Target 2 security service, and the Target Instant Payment Settlement service. And the rationale for the move is more to consolidate all services to allow for central liquidity management across all of their domains. So to enable this, they will be implementing a Euro system single market infrastructure gateway, or ESMIG for short, that participants will use to connect into their provisioned services. This also provides the additional benefit, once we have moved away from the Swift MT message, to change the overall end-to-end flow from a Y-copy flow using Swift to a V-shaped flow, or a V-shaped mode, of which we will go into in more detail. However, a critical point here is that with the move to a V-shaped model, this will take away the requirements for Swift to be the only NSP with the ability to provide connectivity to the services. Now, a lengthy tender process took place and the chosen network partners were Swift and SIA Colt. Why is this important, and more specifically for Box? It's because Box already has the functionality built into the solution to connect to multiple networks. It is a true multi-network platform which already provides connectivity to Swift, SIANet and EBIX for instant payments, along with additional local domestic connections. Now, if you have requirements around redundancy at the level of network vendor, then this can already be provided to you with a single Box solution. For chips, I'll also include Fedwire as it falls within the section of RTGS and high-value payment systems. So just to quickly highlight, the Fedwire is the real-time gross settlement funds transfer system which is operated by the United States Federal Reserve banks. All 12 of them that allow financial institutions to electronically transfer funds between more than 9,000 participants. Now, CHIPS, on the other hand, is a privately run clearinghouse for large value transactions. It's not an RTGS platform. It allows payments for its participants, which are currently between 45 and 50, to be netted. Now, both use proprietary message formats, and needless to say that the Fed and the clearinghouse are currently reviewing their timeline and phased approach to move from proprietary to ISO. From a Box perspective, again, the functionality within Box and the strength behind the workflow message orchestration plays very well into the hands of organizations like these and their participants as they go through the challenges that the move will most likely bring with it. For SGX, which is the Singapore exchange, now we can take this as a great example of the overall Asia Pacific region. We could spend 45 minutes, I think, just talking about the amount of high-value securities and real-time systems that are in place and used today. So I'd just like to quickly highlight a few items specifically around adoption and the fact that the Asia-Pacific region can be seen as the true early adopters of ISO 20022. Now, a number of high-value systems like the China SIPs and SNAP systems, also the India's NG RTGS, Bangladesh's RTGS and the Japanese BOJNet all moved to ISO between 2013 and 2015. And even earlier than that, leading up to today, a large number of real-time instant payment services also took a huge leap forward. Now, what is still to come, specifically in high-value payment space, and of course cross-border, will be the systems like the Singapore MEPS, the Malaysian Rentas, and Thailand's BahtNet. Now, this is by no means an exhaustive list, and also doesn't give you a reflection of the work, of course, taking place with SWIFT for cross-border, and also the security space for trade finance and FX. But it does give you a sense of the accomplishment and work that has already gone into what is still to come. EBA Clearing, or the European Banking Association, is a provider of pan-European payment infrastructure owned solely by shareholders that consist of major European banks. Now, they own and operate the Euro 1, the Step 1, Step 2 and RT1 payment systems. And I think this is a nice transition onto instant payments, where you see RT1, the Target Tip service, the Singapore Fast service and India's IMPS service. RT1, or the Real-Time Instant Credit Transfer Service, is the instant payments option provided by the European Banking Association using the SEPA Instant Credit Transfer Scheme, or SCT Inst for short. This in itself is a standard. It's a standard that mandates the usage of an IBAN and BIC when making SEPA compliant transfers. Now, SEPA data formats are already ISO20022 compliant. However, one of the main issues PSPs, payment service providers, face is the formatting of instant payments and the connectivity into EBA clearing services. This is where Box can also play a key role. Box is already a CNET and EBIC certified product and already supports connectivity and messaging requirements for instant payments using SCT Inst transactions. So to conclude, now we have touched on a few areas here that will be impacted by the move to ISO 20022. From the network providers to market infrastructures to the local domestic RTG or HVP and instant payment systems around the world. So this should give you an idea of the complexity and effort that has gone into and will still need to go into the successful adoption of ISO 20022. So when we see the amount of different MIs and connected participants, either direct or through another financial institution, and you add on top of that the differences in proprietary formats, you start to picture why the overall speed of straight-through processing can be at times relatively slow. And this isn't the first time that a variety of ISO 20022 usage guidelines have been proposed to try to stem the flow of ambiguity between formats and to increase the overall STP time between institutions. However, with each set of guidelines, of course, comes additional complexities. For UDFS, or User Detailed Functional Specifications, it's a good example. Specifically for the Euro system, their real-time gross settlement system, where the use of a ISO 20022 UDFS subset is used for certain inbound and outbound messages. The usage of UDFS, it's a lot greater than just down to message formatting. Functional specifications cover all aspects of the solution for its overall footprint to user access to administration. However, in terms of UDFS version 2.1, which is currently used by target services, this was driven and documented by 4 central banks to create a common framework for ISO 20022, which cover a portfolio of around 50 plus messages. For HVPS Plus, or High Value Payments Plus, this was a SWIFT-driven task force made up of major global banks and market infrastructures. The task force was set up to define and refine global implementation standards and best practices, and which was supposed to meet the increasing demand for higher levels of interoperability between financial institutions, specifically for high-value payments. And one of the goals was to agree on a common framework for the ISO 20022 implementation, which resulted in the usage of 6 core messages. And when we say 6 messages, we're talking about PACS and CAMPT, so PACS 08, 04, 09 and 02, and the CAMPT messages 29 and 56. And the last set of messages, or the last set of guidelines for the messages, which can really be classed as a complete ISO 20022 message format, as this will support the move away from the SWIFT MT to the true ISO 20022 XML format, would be the CBPR Plus, or Cross-Border Payments and Reporting Plus Task Force. The task force again was created by SWIFT in conjunction with a number of major banks and MIs within the payment space. The CBPR workforce is currently being overseen by the Payments Market Practice Group. Once again, their role is to define and refine global implementation standards and best practices, which will facilitate the phased move to ISO for message type categories 1 for customer payments and checks, 2 financial institution transfers, and type 9 cash management and customer status. So you can see that there is a lot of work taking place within this space currently, with an end goal of harmonization across the different actors and institutions. However, true harmonization is a number of years away, which mean that during the coexistence phase of non-ISO and ISO messages, institutions will require the box solution to perform the translation and conversion services so that straight-through processing isn't negatively impacted due to a potential need for manual intervention. And in terms of what this looks like in practice, you can see here the end-to-end life cycle of a message using multiple standards and guidelines. You can see multiple message formats being injected by the customer, from ISO to proprietary to Swift MT standard. Now, once it hits the banking institution, the format and type of message sent on is very much dependent on the receiver. When we talk cross-border, you can see this will hit the guidelines associated with the CBPR Plus Swift move from MT to MX. For the Euro system, as we previously mentioned, you see a usage of UDFS version 2.1 currently, and for clearinghouses for high-value payments, HVPS, PACS, ISO messaging. All different flavors are dependent on the receiver's requirements, of course. And the last leg, due to the fact that institutions can all use a different approach, will be the conversion potentially from receiver format from the specific services or institutions to the right format to send back to the customer. This again shows the level of complexity when a common approach isn't used. So let's now take a deeper look at the move of cross-border categories 129 message types in terms of where it will run from compared to its previous FINMT network rails. So FINplus, what is FINplus and why is it important when we talk specifically about the Swift MT to MX conversion? It's important to remember that all MT traffic sent over the Swift network is sent through the Swift FIN network. The FIN network can now, even though it's been running for the last 40 years, I think it can be seen as the legacy network within Swift. Now, I won't say secondary, so the other network used for live traffic is the SwiftNet network, which for some services bridges over the FIN network, but for MX message sending and receiving, all messages related to the ISO migration, once migrated to the equivalent MX message, will be sent over the SwiftNet Interact network. Now, running on the rails of the SwiftNet network will be the FINplus Interact many-to-many store and forward messaging service, which participants will be provisioned on for payments and securities ISO20022 messaging, as well as CBPR Plus ISO20022 request types. There will be additional request types provisioned on the services for different functions. The Shareholders' Right Directive 2, or SRD2, which looks to improve the dialogue and long-term shareholder engagement with issuers to grow corporate governance. A number of ways they will do this is through the transmission of information from issuer to shareholders without delay in terms of corporate actions notifications, general meetings. They'll also provide identification of shareholders upon an issuer's request. For Central Securities Depository Regulation, the CSDR requires that SCDs must implement a penalty mechanism for late or settlement failures. This will be included in the standards release as ISO SEMT or SEMT 04 request type. And for the GPI Universal Confirmations, due to the removal of the MT199 for tracker status updates and alerts, they will be replaced with the user to tracker updates, the tracker 001 request type, and the tracker to user alerts through the track 003 request type. Now, I mentioned earlier the usage of ISO 20022 for securities, and you can see now that with SRD2 and CSDR, they will be incorporated over the same rails as payments. Now, ISO 20022 is present in the securities and FX markets too. The investments funds industry has adopted ISO 20022 for funds distribution and for other processes. Target 2 securities, the Eurosystem securities settlement system, processes over 1 million instructions per day currently using ISO 20022. And other securities MIs also use the standard, including DTCC for corporate actions. The Singapore Exchange and CLS specifies ISO 20022 for its FX settlement business as an example. So we have now covered what ISO 20022 is, who is impacted, how they're impacted, and some of the constraints that will be faced during the different phases of this journey. So now will be a good time, I think, to look more within Box to see how we will be supporting our customers and working with them to ensure they go through a seamless migration process, or as seamless as possible, with us trying to shield them from the multitude, I think, of issues that may be faced along the journey. So for message entry, it's a good place to start, as complications are faced almost immediately with the move from the Fin network to the SwiftNet Interact FINplus service. With Fin, this is easy as Box performs the standard BIC lookup. Now with the move of messages to MX and over the SwiftNet Interact service, we move away from the bank identification code to a distinguished name, or DN. Now a DN, as you can see in this slide example, follows a hierarchical naming principle. In this example, the top level is Swift, which is followed by the BIC8 of the bank, and then specifying further levels to help route the message to the correct internal recipient within the bank. So to summarize, the distinguished names for production traffic will be derived from the registered BIC11. Now the ISO message as a whole comes with additional complexity. For example, the inclusion of the service name. As an example, this would be the Swift.FinPlus service. Request type patterns, non-repudiation data. So a number of additional technical elements are included. Customers, of course, do not want to deal with this level of intricacy. They want the same as Fin. They want to be able to perform a lookup for a BIC along with the message entry into the system plus message validation. Now this is all provided as part of the migration to MX with Box. In terms of message entry support, the submission profiles where Box stores the technical transfer parameters plus BIC lookup. Now we're able to create the message envelope for the addressing. Now all of this is transparent to the customers, and it takes away the complexity of the move from MT to ISO across the Fin and SwiftNet networks. Now an additional feature to the Swift broadcast service for customers is the Interact multicast, which you can see here. This can be utilized through a closed user group or CUG using a CSV file, which contains the BICs that you want to send your multicast to. This feature that comes at a premium over Swift. With Box, it's built into the solution and will be available for MX messages so that your Swift broadcast over the Fin network can be translated into the equivalent MX message for sending. And one additional feature, which is more of a nice to have, I think, is the mouse hover feature. So you can see what the equivalent MT message would be for the specific MX message just by hovering over the top. Now, there are a lot of packs, camps, SEMPs, different request types out there, and you would certainly be forgiven for getting some of the pairings. Now, when we look at potential exceptions or a need for investigation, we can look at the current approach for Fin. Now, if a request for information is required for a previous message or an amendment to a previous message, an MT195 can be sent. The MT196 in this case would be the response to an MT195 query, or MT192 request for cancellation. The future state is of course a lot more complex due to the amount of additional options that can be provided through the PAX messages outside of what could be provided through an MT like the 195. So in principle, all camped message types have references to the existing stored PAX 8 or 9s as examples. So within Box, the same level of functionality is still available. In terms of payment warehouse, and for those watching that may not have an understanding of what the warehouse is, in short, we're talking about the Box database and tables within the database that store the messages. Now, currently Box provides a warehouse for Fin messages and also a warehouse for MX messages. The MX world is, of course, as we mentioned, much richer in terms of content due to the complexity of the ISO20022 formatting. For Fin, this is fairly straightforward due to a limitation on fields and the request being for sender, receiver, or just general information as an example. We will, of course, go through a period of coexistence, which looks to currently be 3 years. During this period of coexistence, customers may have certain requests for information that need to be pulled from both Fin and MX warehouses. A customer may be looking for a payment, specifically a payment settlement date, amount, creditor, or maybe even a UETR as an example. For this, a third warehouse will be created, which will house the Fin and MX payments. This gives the customer with a very powerful feature where they can search based on a specific attribute of their choice across both messaging standards. How do they search? Again, if you're familiar with Box, you already know this, but a message comes into Box. Box analyzes the message, extracts the data entries from the message, which then populate the payments warehouse table. And as mentioned previously, once you have this content within the warehouse, you can then, through the journals or queues, search and see the requested information within the GUI. And of course, the search criteria and viewing options are down to the requirements of the individual customer. This should show the power of the functionality, but also the level of granularity that can now be achieved. Now, this comes in extremely useful when you have a requirement to pull data from the new payment warehouse. On creation of the journal and queues, and you can see here the authorization and modification queues, you will then be able to see both MT and MX messages, and you're not then concerned if you're looking at data from an MT or an ISO20022 formatted message. And to reiterate once more, this will be very important during the coexistence phase, as it significantly reduces the burden on the customers with having to have duplicate journals, queues, etc. when sending, receiving or searching for messages. And in this slide, what you see here is a CSV representation of the columns of the new payments warehouse. What is included, and even more than that, what can be referenced during a duplicate message check. You can also see clearly under the message type column the level of granularity and richness that can be incorporated into the search function. And how is all of that data represented? Well, like this. You can see again the level of granularity within the search field options, and these are completely customizable for each customer. It's extremely powerful, and I think it really does provide Box customers with a heightened level of efficacy. Now, it's also worth mentioning some of the challenges customers will be faced with, and one of the requests received from our customers was for the ability to run a full text search for MX messages the same way they would for MT messages. Now, this poses an issue as MX messages, they can be up to 10 times larger than FINMT messages. Because of this, the XML extender utility can search through the XML details, but the functions are not comfortable with the partitioning of table space. The constraint can, however, be alleviated by compressing the message and removing any of the kind of AML artifacts that are not required to allow for a full text search. This is the long way of saying that customers will have these challenges, and by working with us, we can alleviate these headaches for them. We now move away from the warehouse and into the actual messages themselves, where message validation is key. Not only to help straight through processing, which is the kind of high level goal, but also to mitigate a number of complications that come directly from changing message types and service models. Box for FINMT messages currently offers 4 levels of validation: semantical, syntactical, network validation rules, and RMA checks. Now, we'll not have the same level of validation for MX, I think that's clear. And this is not down to the limitations within the Box solution. This is due to the evolution of message types and the evolution of the way MIs will now do business. As an example, Swift will not validate the ISO messages for Eurosystem services due to the move from the Y-copy to V-shape model. However, Box can provide certain additional levels of validation, which include the network validation rules, the same as we have for FIN. But we can now include the message definitions from My Standards and the user handbook recommendations, as you can see in the slide. So in fact, the level of validation is now much richer than it was before. In the examples here, you can see semantic constraint violations for PAX 008 messages at the network validation and message definition level. Not only are you given the recommendations for how to mitigate the issue, but you're also given the XPath, the rule, the user handbook code, and the user handbook severity. These are, of course, additional layers of verification that we've been able to harness within Box, but this doesn't take away from the previous levels of validation that took place accordingly to the specific designs of each customer's requirements. Even before a message leaves Box, the entire message goes through a validation check to ensure the validity of the message is correct prior to sending, be it semantical, syntactical, or cross-field validation. And of course, if an issue is found, it's flagged for investigation. And also, when we discuss RMA later, this is also a check built into the workflow to check for a valid RMA even before the message leaves the system. I think this really goes to show how much protection is built in, and also the speed you can react if any issues are found. This will significantly cut down the time it takes to investigate failure situations and to be able to modify, send or cancel dependent on the specific situation. All of this would have to take place within the back office or additional middleware solution. With Box, this is built directly into the workflow. Okay, now we move on to one of the most significant items related to the move from MT to ISO 20022 MX messaging for Box. And it's worth mentioning before we look at this that we are heavily dependent on the work being completed by the CBPR Plus working group to provide to the community the set of conversion rules. Now, I mentioned earlier that the job of the CBPR Plus working group is to define, refine and provide the global implementation standards and conversion rules to the community. Within Box, it's important for our customers that they have a level of normality in the way the user interface looks, that MT and MX messages have the same look and feel, and you can see in the slide that the GUI looks the same and the tab structure looks the same even when viewing an MT or MX message. Also, that the routing capabilities are the same or at least transparent in the way they work. Now, one area that is a concern and should be a concern to the community during the coexistence phase is the management of truncated data that we will look at now in more detail. Now, one of the biggest challenges to the community is how they manage the conversion from MT to MX, but maybe more significantly, the move from MX to MT. As we said earlier, the size of an MX message can be at times maybe 10 times the size of a FIN message. This also means the size and length of field tags can be longer than the equivalent MT. Box can handle the data truncation, and we can give the user the options to modify, compare and check the results of the transformation and conversion, and also be able to see that a message content is indeed valid. In this slide you can see, for this example, the original MX message option and the associated validation errors or warnings that were found during the conversion from MX to MT. Now you can also see within the error the message content entry field tag where the failure took place, and below the MT message with message content 13C highlighted red with the failure. Let's look a bit deeper into the potential this level of failure checking provides. And what we see here is a view of a PAX 009 message. Not all of the messages shown here, of course, but you can see the fields and how they are represented. So you see tabs for the application header, the actual PAX 009 message, transaction data, journal application queue data, history, and also the transformation data. And more importantly is the view you now see within the transformation data tab, which shows you the transformation data of the original MT message. So you have the equivalency between the transformation data tab and the message tab. And as I mentioned earlier, to move from MT to MX can be seen as relatively straightforward if you're using Box to convert your messages. However, from MX to MT, this can provide significant challenges. These challenges will need, of course, to be manually investigated if you are not using Box, and this could be down to the level of individual field lookups to ascertain where the potential failure could be. Now, this is time consuming and something customers do not want to perform. So within Box, you can see a number of areas that pose risk during the conversion. Now, these were triggered by the Box workflow during the conversion phase. The TRN, as an example, could be too long. The UETR for GPI tracking could be too short. And these are just a few examples that you will face if your conversion mechanism isn't up to par with what Box can provide. What's also important to note here is how Box stores the messages. And what you see here is the internal representation of a Box message. At the top of the message, you can see the FINwire MT message details, and below you see the corresponding PAX information. In this instance, PAX 008 message details, and this is in principle how Box handles the storing of messages. We receive the PAX and create the FIN message, and we keep all of the information together within the same message. Now, this is very important. The additional data is not kept in a separate comment section. It's kept within the XML structure of the actual message. And in some instances, truncating data might not be the best option. So Box provides additionally the ability to create an invalid message. The example here shows that we can clearly see that within the message content sender's reference, the content of the tag has been flagged as being too long. So already a level of validation has taken place before we decide on the next steps. In this instance, instead of truncating the data, we create an invalid FIN message with all of the data provided. And then you can see within the original MX message, the validation failure showing that the TRN in this example is too long. If you then were to click on the validation failure, you are now taken to the FIN empty message within the original MX message. And you can see the error and you are directed to the field that caused the problem along with the error description. Again, this is extremely powerful that you have this level of granularity within the message itself. So what does this actually provide you with? Well, what it provides you with is the message transformation data with the failed transformation list. So every field that causes problems during the MT-MX conversion is listed here. And we can use this then within the box workflow to perform a secondary level of conversion, to say what should happen to the data and what rules should sit behind it to fix the issues and resend the messages. Customers will of course want to apply their own rules, which can also be built within the workflow, but all of this takes place transparently to the customers. Now the MT-MX conversion I think shouldn't really be taken too lightly. It's a significant hurdle that will need to be managed by all customers that don't use Box as they move through the coexistence phase, and as you can see, the possibilities with Box are significant. Now when we look at the V-shaped model, you can already see this differs greatly from the Y-copy approach. Instead of the copy mechanism, which requires authorization before sending, we now have a direct link, be that through Swift or C-Occult, to the Eurosystem services. Now Bank-A will send a message directly to the MI platform. In this instance, it's a PAX 008. Upon successful validation within the target service, it's an optional step for the MI platform to send a settlement confirmation, a PAX 002 message, back to Bank-A. This is, of course, very important because without it, how can we ascertain successful receipt of the message within the target service? And once successful validation takes place, the target service will then send the payment message to Bank B. So what is extremely important for our customers, even outside of our ability to fully support the ESMIG protocol for both SwiftNet and CNET, is our ability to reconcile within the Box solution. So between the PAX 008 or 009 against the corresponding PAX 0204 or ADMI 07, dependent on the situation, of course. And we do this so that the customer can check on the receipt of payments delivery reports against the PAX 08 or 09 originating credit transfers. Additionally, a customer can also receive an incoming message, of course, and Box provides the ability to manually or automatically send the PAX 02 as a response. And the last important area here that we need to cover is that we also do this so that we can benefit from the waiting instruction. As there isn't a copy using the Y-copy mechanism anymore, we are waiting on the MI to process that inbound message. And we can set up through the workflow the ability to wait until the response is received before reporting to the customer's back office. Now we've covered a lot of information here, and with the new terminology that comes with this evolution, it can take time, of course, to understand all the different message types, guidelines, specifications and flows. What I can say though is that with Box, you're shielded from a lot of this through the solution. If we look at message transformation, and this really is just to build on what we've just covered, the power of Box is truly built within the workflow of the system and through the XSLTs that handle the XML. Now, if you don't know what XSLT is, you can Google it. The terminology isn't specific to Intercope, but the level of intricacy of the development within Box is what makes its usage so powerful. This can, of course, be provided as an additional service to our customers so that our customers can then implement it themselves. In the use case example here, you can see a PAX 08 being received by Box, which is then converted to an MT103, which could potentially contain truncated data. Now, the MT103 will then be sent for processing within the institution's payment hub. The MT103 could then be forwarded, which may require a change potentially in the beneficiary. and also be required to be converted to a PAX 008. However, at this point in time, the new PAX 008 could potentially be different from the originating PAX 008 due to, of course, the potential of truncated data within the original conversion. Box is able to get around this issue by taking a look at both PAX 008s and mirroring the content to ensure a final PAX 08 is created which contains all of the correct data before sending. And again, this really shows not only the power within Box, but also the complexity that customers are going to face as we sit within the coexistence phase. Okay, so we changed direction slightly here, but we're still looking at XSLT. In terms of sanction screening, there really isn't too much that we need to cover here. However, there is one very important point that should be known by all customers that will impact the way they send messages into their embargo platforms. When an ISO MX message is received by Box that requires screening, the initial screening has to take place using the original message that comes into the system. Now that doesn't matter if it's from Box, it could be into any platform, but that initial screening has to take place with the original message. You cannot perform a conversion from MX to MT and then screen the converted message, okay? The same, of course, is true for MTs, but embargo systems are already set up to handle the receipt of MT messages. It's an important item because institutions will have to ensure that their embargo systems are set up to receive MX messages. We have a lot of experience in this area and the workflow set up to perform the work currently, which again takes place through the XSLT translation, which can create the correct format for the embargo system and can be easily created or modified to handle incoming MX messages. So the last area that we need to cover is the evolution of RMA or relationship management application. The business relationships that you have created with other users on the Fin service, which carries your MT1209 traffic currently, will need to be replicated across the new SwiftNet Interact FINplus service. Now this will need to take place using a phased approach. Before the migration starts, Swift will provide a file that contains the new ISO20022 RMA relationships, and this will need to be uploaded into Box. Now the replication will be based, as I said, on your existing RMA relationships. So this is a good time to perform maybe a level of rationalization across your current RMAs, maybe in the context of financial crimes or security compliance. And transactions that are missing a valid RMA, they will be nacked at Swift. So let's look at some key highlights that are worth remembering. As mentioned, the central database currently used for Fin authorizations or relationships will be expanded to the new SwiftNet Interact FINplus service. The replication of MT relationships to MX will be provided through a file, and the conversion will also include granularity, also not just, for example, sender and receiver information. Now the messages used to interact with the GPI tracker, we mentioned it previously, for example, the tracker 001 and 3 messages will not require RMAs. And if a message does not require RMA in Fin, then the equivalent MX message will also not be required to have a corresponding RMA. With the move to ISO, a particular PAX message could have multiple MTs that are linked to it. So in this case, if one of the two MTs is authorized, then the equivalent MX message will also be authorized. And what you see depicted here within the RMA data store in Box is the coexistence of both Fin and MX RMA records. Now this provides, once again, the flexibility of a single location for reference rather than a segregation of records until we complete the 3-year coexistence. And literally the last item to mention, which was available even before we started talking about ISO, is the RMA fast permission check. Now this is used by the back office who can send a request into Box to check if the RMA records exists before actually sending a message into the system. With the move to MX, this feature still covers all service types, be it Fin, FileAct or Interact. Okay, so with that, we will draw this webinar to a close. As mentioned at the beginning, the intent of this session was to provide you with an overview and increase your knowledge of the implications ISO20022 is going to bring as we move forward. And more importantly, what Box can provide you in terms of an overall solution and specific areas of functionality that will hopefully alleviate a lot of the issues that you will be faced with. Now, if you have additional questions or you would like to discuss how we can help you, then please contact me at the email address shown here in this slide, or contact our head office directly on the number provided. Okay, so with that, I would like to thank you all for joining us.